Section 6.1 of the guided notes. So a function that can be represented in the form of f of x is equal to a times x squared plus bx plus c is called a quadratic function. Quadratic. The terms a, b, and c are constants where a is not equal to 0. The greatest exponent of the variable x is 2. So, right, this right here is basically a x squared. And the largest power of a quadratic function is to the second power. And the most basic quadratic function is f of x is equal to x squared. And there, hopefully, before we took these notes, right, you had some experience building on Desmos, the calculator for a quadratic function, and all the different translations and transformations of the function compared to the parent function. But let's just take a look. If we select a few values for these, right, this winds up being, let's say, the f of -1. If the function is x squared, right, it's basically -1 squared. So that's going to equal 1, right? 0 squared is 0. 1 squared is 1. And f of 2 is equal to 2 squared, which is 4. So all of these are various points on the graph, right? We have -3 and 9. That's way up here. We have -2 and 4. That's there. -1 and 1. Right? And now this is starting to take shape as we graph this. And the graph of a parabola is kind of like a cup or a U, if you will. And I mean, that's what this thing is called, right? This is called a parabola. And, right, this is basically a quadratic function. So the curve itself, right, that's called the parabola. And the point through which the parabola turns direction is called its vertex. And what else here? Let's see. The vertex occurs at 0, 0 for the parent function. A vertical line that passes through the vertex and divides the parabola into two symmetrical halves is called the axis of symmetry. And I just want to go back to the prior page. It's all the same page for you, but it's the prior page on my slide. Right, the axis of symmetry, I'm going to do in a different color here for this parent function parabola. Right, this kind of divides the parabola into two equal halves. And the axis of symmetry is in fact the y-axis. So I just wanted to highlight that. And carrying on with our notes here. Right, hopefully in the worksheets that we did before, these notes, you got to see, well, when a was bigger than 1, right, the graph of the function became narrower than the parent function. And right, this one's here is probably the parent function. And this one here has been basically stretched. And this stuff, by the way, is actually the identical rules that you had when you were doing absolute value from chapter 2. So, and then here again, here's the parent function. This is the parent function. But a vertical compression, right, it's going to be a fatter graph. So this has been compressed. And that happens when a is between 0 and 1, as described right here. Now, another important thing to notice is just like absolute value, right, domain is all the possible values of x. So what could x be? It looks like x could be everything. So the domain of these things is always all real numbers. And just like absolute value, the only thing that varies is the range, right? For this particular parabola, the range in interval notation would be from, it looks like 0, and it actually includes 0, so I'd have that sideways staple, all the way to positive infinity. But depending on how this has been transformed, up, down, left, or right, the range is going to change. But the domain is always all real numbers. And just like an absolute value, right, here we go, the domain of a quadratic function is all real numbers. When a is bigger than 0, then the graph of g of x is equal to ax squared will open upward. And the function has a minimum value that occurs at the vertex. And then the range of the function is the range of g of x equal to ax squared, where a is greater than 0. That's supposed to be an a. Is a set of real numbers greater than or equal to the minimum value. Basically, from the vertex up. And conversely, if it's going the other direction. So let's take a look at this function. And we've got y, or g of x is equal to 1/2 x squared. So g of -3 is equal to 1/2 times basically -3 squared, which winds up being 9/2. And then g of -2 is equal to 1/2 times -2 squared, which is basically half of 4, which is 2. G of 0 is 1/2 of 0 squared, which is 0. G of +2, 1/2, 2 squared, right? And here you notice some symmetry, right? If this is, right here, this is going to be our vertex. And how can I tell? Because check out the symmetry here and here. Chances are this point is going to be 9/2. And let's see if it is. G of 3 is equal to 1/2 3 squared, which is 9. So 9 times 1/2. And it sure is. So let's plot our graph. We've got 0, 0 is a point. We've got -2 and 2 is a point. We've got +2 and 2 is a point. And then we also have 3 and 9/2, which is, right, slightly more than 4. Slightly more than 4. 4.5 to be exact. So here you go. This is your parabola, at least the general shape of it. And again, it's like a U or a cup. And the domain is all real numbers, because that's what it always is for parabolas, and I should say for quadratic functions. right? This is always the case. And then the range, well, what's our minimum value, right? From the vertex up. Our minimum value is 0. So it's going to be 0 to positive infinity is our range. So hopefully this is some of this intro stuff I know is, I don't know other way to describe it, but very, very mathy, right? Lots of formulas, lots of concepts, definitions. But this stuff is a lot easier than it may appear. And we're just basically plugging in values for x, getting values for y, and following the rules of the formula that it wants us to follow. So here we go. The graph of y is equal to, and I'm gonna rewrite this because sometimes when I type these out, it doesn't come out the way I intended. So the graph of y is equal to negative x squared. That opens downwards, right? That's going to basically be an upside down cup or an upside down U. It's a reflection of the graph of y equals x squared across the x-axis. So when a is less than 0, the graph of g of x equals a times x squared puts downward, and the function has a maximum, oops, I hit the wrong button. Sorry for the technical difficulties, has a maximum value that occurs at the vertex of the parabola. So right up here is the max. When it opened down here, we had a minimum, right? This is a min value. This is a maximum value. That's really all this is trying to say is, don't get any funny ideas about what these parabolas look like. But that's all, right? The vertex is the max, or it's the min, depending on whether if a is positive or negative. That's supposed to be an A. So let's take a look at some more stuff here. You shrink this down a little bit so you can see the rest of this graph. And right here you see a is bigger than 0. The graph of g of x is narrower than the parent function. And right, vertical stretch and compression, it's just illustrating again, here is, right there is the parent. Right there is the parent function. Right there is the parent function. And right, if it's between 0 and 1, right, we're talking about a compression. Particularly if we're talking about something that opens downward, right? This is what a compression looks like when a is negative. And this is what stretch looks like when a is negative. I keep hitting the button to flip the page, so I'm sorry about that. But then I have to restart the whole recording, and I'm just not going to do that. So you can deal with the little technical difficulty. And what else? Oh, right. When a was negative, we were reflecting across this x-axis, right? This was reflected. And we actually already seen this in the worksheets I had you do before these notes. And now let's take a look at an actual function. So g of x is equal to negative 1/2 x squared. So we're going to find, well, what's g of negative 3? That's going to be negative 1/2 times negative 3 squared, which will wind up being negative 9 halves. G of negative 2, negative 1 half, times negative 2 squared. Right, this winds up being negative 2. And when we get to 0, it equals 0. So here we go. I'm just graphing the various points. And of course we have this axis of symmetry, which kind of makes graphing a little bit easier for us. And because all these points are going to follow this symmetry, and the axis of symmetry is, of course, right, it divides the vertex, right? Here's the vertex, and perfect mirror image on either side. So what's the domain? This should be a trick question, right? It's always all real numbers. Oh yeah, let me draw the shape of our parabola, our quadratic function. What's our range, right? In this instance, the vertex is basically a max value, right? This function will never go higher than the vertex, which makes the vertex the maximum value of the function. So the range is going to be from basically, from negative infinity up until 0. Another way to write that is y is less than or equal to 0. So we're almost done. Let's take a look at this this example, and it talks about, well, how would I write a quadratic function if I was given a graph? I know that's a common problem you have, right? Something you're having to solve in your everyday lives. And I'm being a little bit sarcastic, but let's say, for instance, you actually just had the graph and you didn't know what the function is. This right here walks you through, all the steps involved. So then they have you do a sample one, right? And we can use the point. This is negative 2, negative 8. And it says, we'll start with this basic function form. Well, I know one thing. I know a is negative. And why do I know that, right? I mean, we got an upside down parabola. And remember when we were doing absolute value? When they were upside down, a was negative. It's just that simple. It gets flipped. It's reflected over the x-axis. But we can actually figure out the value of a by using the points that they give us, right? This is an x point, and that's a y point. And all that means is that this function is equal to negative 8 when x is negative 2. So if x is negative 2, right, what's negative 2 squared? That's 4. So 4 times whatever a is equal to a negative 8. So that must make a equal to whatever negative 8 divided by 4 is, and that's negative 2. So, and here we go. Divide both sides by 4 to isolate a. Here's your final function. G of x is equal to negative 2 times x squared. And that's one way to solve for the quadratic function given the graph alone. So there you go. That's this section's notes. And then now we're going to move to guided practice.